Calculus 1 Final Exam Review, Problem 18. Because the integrand is a sum and/or difference, we can find antiderivative term by term. For the first term, we use the power rule. We add 1 to 3 halves, and that gives us 5 halves, and we divide by that new exponent 5 halves. The next one is probably most easily explained, although you could use a power rule, by the common calculation that the derivative of x squared is 2x. How many times have we seen that? Therefore, the antiderivative of 2x is x squared, plus a constant, of course. And what do you take the derivative of to get 1? X, of course, plus c. Dividing by 5 halves is the same as multiplying by 2/5, and here we have our answer. In part B, we have a difference of terms, so we can form two integrals. Constant multiples can be factored out. The antiderivative of sine of x is negative cosine of x. The antiderivative of e to the x is e to the x. Our answer is negative 2 cosine of x minus 5 e to the x plus c. In part C, we have a difference, so we can form two integrals. Let's factor the multiplied constant 5 out of the second integral. Since we have an implied exponent of 1, by the power rule we add 1 to that, giving us 2. Divide by that new exponent. The antiderivative of 1 over x is natural log of the absolute value of x plus c. Here we have our answer. When you have a quotient, as we do here, of course you can't integrate the numerator separately and the denominator separately. Just like taking the derivative of a quotient is more complicated than what you might think if you had not studied the quotient rule. Because the denominator has a single term, we can distribute that division across the subtracted terms of the numerator. By properties of exponents, we subtract 1 minus a half, giving us 1/2 power. This 1/2 in the denominator is equivalent to u to the negative 1/2 in the numerator. So let's integrate now. I will leave off the limit values, 1 and 4, until we find the antiderivative. We have a difference, so we can integrate each term separately. Adding 1 to 1/2 gives us 3 halves. We divide by 3 halves. If we add 1 to negative 1/2, that gives us positive 1/2. We divide by the new exponent. I won't write the plus c because we have a definite integral in mind. Simplifying, we get 2/3 u to the 3 halves, and 2 divided by a half. How many 1/2s are in 2? 4. So minus 4u to the 1/2. Therefore, this definite integral is equal to, by the fundamental theorem of calculus, what we get when we replace u with 4, take away what we get when we replace u with 1. So 2/3 times 4 to the 3 halves minus 4 times 4 to the 1/2. Subtract 2/3 times 1 to the 3 half minus 4 times 1 to the 1/2. Did I say 3 half? I meant 3 halves. So here we square root 4. That gives 2. 2 cubed is 8. Square root of 4 is 2. 1 raised to any power is 1. 16/3 minus 8 minus 2/3 plus 4. 16/3 minus 2/3 is 14/3. Negative 8 plus 4 is negative 4. 4 is equal to 12 divided by 3. We wind up with an answer of 2/3. Let's find the antiderivative first. We have a difference, so we can go term by term. Add 1 to 1/3, that gives 4/3. Adding 1 to 2/3 gives 5/3. I won't write the plus c because we have a definite integral in mind here. Dividing by a fraction is the same as multiplying by that fraction's reciprocal. So therefore, this definite integral is equal to what you get when we replace this t with 0 and then with -1. Here we have 0. This is the cube root of -1, which is -1, and then raised to the 4th power is +1. 3/4 times +1 in a parentheses minus cube root of -1 is -1 raised to this odd power 5 is -1. That is 3/5 times -1. So we have negative of the quantity 3/4 plus 3/5. 3/4 is 15/20. 3/5 is 12/20. Our answer is -27/20. In part F, our denominator involves a composition with an inside function of 1 minus x squared. When you see that, you make this attempt. Use substitution where, in this case, u equals 1 minus x squared, the inside function of that composition. Now we see if we can account for all the other components of the integrand. Du, the derivative with respect to x, would be -2x dx. And we can account for all the other components of the integrand, with the exception of that -2. But you're allowed to multiply in constants, as I do here, as long as you pay for it by multiplying by its reciprocal. -2x dx is exactly what we call du, and the denominator is the square root of u. We have a power function. We have u to the -1/2 power as our integrand. For the antiderivative, we add 1 to that -1/2. -1/2 plus 1 is +1/2. And we divide by that new exponent. Start writing plus c. Now any number divided by itself is 1, with the exception of 0 divided by 0. 1/2 divided by 1/2 is 1. We do have that leftover negative sign, so we have -u to the 1/2 power plus c. The final answer must revert to the original variable x, so we have a negative of 1 minus x squared to the 1/2 plus c. In other words, negative square root of 1 minus x squared plus c. In part G, we have a composition where the inside function is pi times x. So we are going to try this by letting u equal that inside function, pi x. Then du, the derivative with respect to x, would be pi dx. And notice that's exactly what we have in the rest of the integrand. So we have sine of pi x, that's sine of u. We have pi dx, that's du. The antiderivative of sine of u is negative cosine of u plus c. Back to the original variable, there is our answer. This one looks scary, doesn't it? Well, here we have a composition where the inside function is x squared plus 2x. Let u be that inside function. The derivative with respect to x is 2x plus 2. Algebraically, parentheses are needed. Does that look like the rest of this integrand? Let me show you. Factoring 2 out, we have 2 times the quantity x plus 1 dx. The integrand has everything except for that 2, which I will multiply in and pay for by multiplying by the reciprocal. So e to the x squared plus 2x is e to the u. And 2x plus 1 dx, that's du. The antiderivative of e to the u is e to the u. Back to the original variable, here is our answer. In part I, since the denominator has a single term and the numerator is composed of a difference, do a little bit of preliminary algebra work. We can distribute this divided 7x across this subtraction. X squared divided by x gives us 1 power of x in the numerator. These 7's divide to 1. It's a difference, so we can form 2 integrals. We can factor out this multiplied constant of 1/7. And these 2 integrals we saw earlier in the video. Add 1 to this exponent gives us 2. Divide by that new exponent. The antiderivative of 1 over x is a natural log of the absolute value of x. So here is our answer. This one probably looks complicated too, but again, if you see a composition, as we have here, we are going to try letting u equal the inside function of that composition, which is natural log of x. What is du? The derivative of the natural log of x is 1 over x, and that's what we have here. So natural log of x squared is u squared. 1 divided by x dx, that's du. Power rule gives us u cubed divided by 3 plus c. Back in terms of x, natural log of x cubed divided by 3 plus c.